graphing quadratics in vertex form. We saw standard form. Now here's the vertex form. So we got first two examples of this worksheet. We'll do these out in its entirety, and then we'll go from there. So we have the y equals quantity of x minus 4 squared plus 1. All right, what I want you guys to right above this, right? So y equals or f of x equals, right? This is the same exact thing, right? And we've worked with f of x equals, right? And we have a times x minus h, a times the quantity of x minus h squared plus k. All right, so we've seen this form at this point from the previous sections in the book. We have talked about the a value. Okay, so a is your opening. So if a is positive, right, it's opening up. If a is negative, it's opening down. All right, if a is greater than 1, right, then we have a vertical stretch, right? And if a is less than 1 and greater than 0, then it's a vertical shrink, right? And this is just, and these rules apply for any function that you have, all right? And now we also have an h. The h value is the horizontal shift, and then we have the k value, which is the vertical shift. All right, so just a couple things to jot in your memory here. All right, your horizontal shift can move left. Oh, we get a different color there. Your vertical horizontal shifts can go left or right, and your vertical shift can be up or down as being vertical. All right, so a couple rules here. And then another big piece here is the h and k, and I'm just going to highlight those with my little highlighter here, h and k. And the h and k is something crucial to us. This is our vertex, right? So our vertex is h comma k. So what is h? What's a? What's h? What's k? And there's actually a b value in here as well. And there's a b value here in front of your x that we're not going to talk about this year. We'll leave that for Algebra 2, and then they'll get into the effects of the b. But let's leave it at this for now. All right, so what's my a, what's my b, and I'm sorry, what's my a, what's my h, and what's my k? So a is, in this problem, 1, right? So that's my leading coefficient. H is 4, not negative 4, right? Because my formula is x minus, right? And then whatever this number is my h. Right? And then k is just positive 1, right? So all these numbers are positive, great, so positive 1, h is positive 4, and k is positive 1. So that means my vertex is 4 comma 1, right? Based off of my h and k. So 4 comma 1, 1, 2, 3, 4, 4 comma 1, and there's 4 comma 1, and there's my vertex at 4 comma 1. All right, and I know this is positive, my a value is positive, so I know my u shape is going to go somewhere going up in that manner because it is, my a value is positive, and we're going to get a couple values there and figure out where it's actually going. All right, and what I would do is find your vertex, right, and then find yourself a number above the vertex. You could do one above. So what is f of 5? So if you wanted to, you have 1 times 5 minus 4 plus 1. Don't forget the square there. And this is just going to be 5 minus 4 is 1, 1 squared is 1, 1 times 1 plus 1, and you just get 2. So f of 5 is 2. So f of 5, you get 2. Now, from the previous video that we did on standard form, we also know that we have an axis of symmetry here, so I'm just going to abbreviate AOS, and my axis of symmetry is going to be x equals 4. Right, so that's going this way right here, and so it's going to be the x value of the, oops, just joking, it's going to be the x value of, stretch this out, and beautiful, so x equals 4 is always going to be the h value or the x value, x equals the x value of the vertex. So we have x equals 4, so if my coordinate is 5 comma 2, right, and my vertex is 4, so if I move 1 to the right and I'm going up 2, then I'm going to move 1 to the left and I'm going to go up 2. Right, so these 2 points will always be symmetric about one another. All right, so you have your vertex, you have 2 coordinates, you have a coordinate to the right, you have a coordinate to the left, you have a general shape of this. You can go a little more if you want to. That's up to you. So f of 5, like we just said, f of 5 is going to equal f of 3 based on the axis of symmetry, right? So 4 is my middle. Move 1 unit to the left, I get 3. Move 1 unit to the right, I get 5. My y value will be the same for both. And if you want to, again, you could give yourself a couple more values here, but for today, I'm just gonna practice graphing in vertex form, okay, and nothing more. And then we'll get a little deeper into different concepts here in the next couple next lesson. All right, so here's another one. So we got y equals 2 times the quantity of x minus 3 squared minus 3. All right, so I'm just going to rewrite this standard form here, or its general form. So it's x minus h squared plus k. I always love to identify my a, h, and k. I got a is 2, h is 3, and k is negative 3 this time. All right, so a is 2, so that means a is greater than 1. It's positive, so it's going to be opening up, and I have a vertical stretch here. Okay, so we have a vertical stretch by a factor of 2, right? H is 3, which is also greater than 0, so I have a horizontal shift, 3 right. And then the last one here is k is negative 3, so I have a vertical shift, 3 down. All right, so vertex is my h comma k. Perfect. So my h is 3, my k is negative 3. Off to my graph. 1, 2, 3, down 3. 1, 2, 3. Voila, there's my vertex. Cool. With the vertex comes the axis of symmetry. All right, it's not asking for it, but I like to put it there. It's going to help me graph some of this. So at 3, there's my axis of symmetry there. All right, so everything's going to be symmetric about that point. And now I need a couple more points to graph. All right, and so if my x, so I have x and f of x, and what I was saying before was if this is 3, so we have 3 comma negative 3. If I go 1 unit to the left of 3 and 1 unit above 3, these two y values should be exactly the same. So whether I plug in 2 into my equation or 4 into my equation, I'm going to get the same exact y value. So the question is, so f of 2 is going to equal f of 4. So plug in, let's find one of those. What is f of 4? F of 4 is 2 times the quantity of 4 minus 3 squared minus 3, right? Just plugging in 4 for x. All right, I'm going to go inside the parentheses first. 4 minus 3, 1. Squared. 1 squared is 1. 1 times 2 is 2. 2 minus 3 is negative 1. So f of 4 is negative 1. That means f of 2 is negative 1. So when f is 4, I get negative 1. When f is 2, I also get negative 1. And again, you can verify that if you want to. So that means if I chose another value of 5, right, 2 units from 3, and then 2 units from and 1, and I played with that one, I could get another value. Let's go with one more here. So what is f of 5? So it's 2 times 5 minus 3 squared minus 3. All right, inside my parentheses, right, I'm doing 5 minus 3 first. 5 minus 3 is 2. Then I square it. 2 squared is 4. I multiply by 2. 4 times 2 is 8. And then subtract 3, and I get 5. So at 5, I'm at 5. 1, 2, 3, 4, 5. All right, so that grew pretty quick there. And that means at 1, I'm also at the same height as the last one. Okay, and then now I have enough to give myself a general U shape here. And this one's growing rather quickly, and that's because I have a vertical stretch. I'm growing twice as fast as I normally would be growing if my A value was 1. We're going to do one more for fun. We're only 9 minutes in. Let's see if we can bang this one out in the next couple minutes. All right, so now let's write again. I'm going to write my f of x equals the vertex form of the parabola plus k. All right, so a times the quantity of x minus h squared plus k. What is my a? A is negative 2. Okay, what's my h? h is, looks like positive 3, but it's not. It is negative 3. And what is my k? My k is negative 2. So let's take a second and figure out why this is negative 3. All right, so be careful. This really, I'm going to rewrite this as y equals negative 2 times x minus, and that's going to mimic everything up until this point here, right? X minus, right? That's all this, right? There's an x minus in my general form. Well, in order for me to get this positive 3 here, well, then my h value has to be negative 3. Right? And the rest of it stays the same. Because then, when I have, if h is negative 3, then these two minus signs will make one big plus sign. And that's how I could rewrite this as negative 2 times the quantity of x plus 3 squared. Right? So be careful there. That plus sign inside means your h value is negative. All right, so the fact that this is negative, that means my opening is down. The fact that this is greater than 1 means that there's a vertical, that says vertical stretch by a factor of 2. My h, my h is negative 3, which means I have a horizontal shift 3 left. And my k is negative 2, which means I have a vertical shift 2 down. All right, so the a value doesn't affect your vertex. All right, so let's get my vertex on here. So my vertex is, all right, so my vertex is, again, that's my h and my k. And in this case, my h is negative 3 and my k is negative 2. So 1, 2, 3 to the left, 1, 2, 3 to the left, and down 2, and there is my vertex. All right, now, the fact that it's negative, that means this graph is going to go down, right? It's going to be a U shape going down, all right? But we'll get a couple values in there to make sure we're going in the right direction. My axis is symmetry, right? Nothing changes there. X is equal to, it's always the x value of your vertex. X is equal to negative 3. So I'm going to put a line of symmetry there just to guide me in my graphing. All right, and then I'm going to pick a value for x that want to help me graph this. And I'm going to pick a number to the left of and to the right of x is negative 3 on the number line, so negative 2 and negative 4, right? And that will give me the same y value, okay? F of 2 will equal negative 4 because I went 1 unit to the left of negative 4, 1 unit to the right of negative 2 on the number line. If I went to negative 5 and to negative 1, again, f of negative 1 is going to equal f of negative 5. So you don't have to do the math twice. All right, the math for f of 2 and f of negative 1 will be suffice to get you the same y value for f of negative 4 or f of negative 5. All right, so that's how I'm choosing those values there. And let's see what we got here. So I'm going to plug in f of negative 2 here, and I got negative 2 times the quantity of negative 2 plus 3 squared minus 2. All right, so inside out, so negative 2 plus 3, this is 1, square 1, you get 1. 1 times negative 2 is negative 2, negative 2 minus 2 is negative 4. So f of negative 2 is 1, 2, 3, 4, negative 4, which means this is also negative 4. Okay, then I'm going to plug in, I'll do f of negative 5 for no other reason. Negative 5 or negative 1 doesn't matter, right? So this is going to be negative 2 times negative 5 plus 3. Oops, looks like times 3. Plus 3 squared minus 2. All right, inside out. Negative 5 plus 3 is negative 2. Negative 2 squared is, negative 2 squared is 4. 4 times negative 2 is negative 8. Negative 8 minus 2 is negative 10. All right, and go as fast or as slow as you want on that. Just take your time, make sure you get that right. And down to now negative 10. So f of negative 5. So here's my negative 10, and f of negative 1 is also going to give me negative 10, and that's going to give me more than enough to draw my U shape here. All right, so there's 3 examples using the vertex form to help you graph. different from the standard form. We found the y-intercepts, we found the x-intercepts in the last one, and in the upcoming chapter, we'll figure out how to get your x-intercepts from vertex form, how to get your y-intercept from vertex form, and then how to get standard form into vertex form. So all coming soon. See you guys in a few.